So this video is going to talk a little bit about orbital notation, electron configuration, and dot diagrams, as well as how we deal with some ions. So if we start off, let's just do something that we already should be familiar with, that should be reviewed if we're going to symbolize the atom. And this number one here really deals with carbon. So we know that the symbol for carbon is C. And if we look on our periodic table, what we see is that carbon actually has an atomic number of 6. And what that atomic number represents, remember, is the number of protons. And the element, as long as it's neutral, that number of protons is going to equal the number of electrons. So we know that carbon should have 6 electrons when it's neutral. What we also know is, again, remember this is an atomic mass. It's an average of all the different isotopes. So carbon normally has a mass of 12 and an atomic number of 6. So if I'm filling out my symbol here, it's going to have an atomic number, which we put in the bottom left, and of 6, and a mass number of 12. So what that boils down to is 6 protons, 6 neutrons, and 6 electrons. So a little bit of review there as far as how to do those. So then we go to our orbital notation, electron configuration, and we want to map out these electrons. Remember that this is really just almost like an address of where these electrons are located. So our orbital notation, that's going to be the arrows, right? The up-down arrows. And our electron configuration is going to be that, 1s, 1s2, 2s2, all that stuff. So, and I'll show you how to use the cheat sheet that you can use on your test here as we're going along. So, so above this dotted line, we'll do the orbital notation for carbon. And again, 6 electrons that I have to map out here, 6 electrons. And I'm just going to start off, instead of boxes like you see on that cheat sheet, I'm going to just, instead of drawing a bunch of boxes, I'm going to use lines. So when we look at this cheat sheet, and you can fill in the arrows in these boxes, but remember, Aufbau says we need to fill the bottom energy level, right? These are increasing in energy level as we kind of go up, this table. So in that 1s, right, we can have 2 electrons. Each box can contain 2 arrows, or 2 electrons is what those arrows represent. So at this point, I've got 1, 2, 3, 4, 5, and 6. And the reason why I put an arrow in that second box is because Hun tells us, the bus rule, that they're not going to pair up until they absolutely have to. Almost like if you get on the city bus and there's somebody sitting in one seat and there's 2 open seats, well, this electron is just like you. It's going to go find its own seat. So that's our orbital notation for carbon. That's got our 6 electrons. And this is just a vertical form. So what I'm going to do is I'm going to write that in a horizontal form. So instead of using up all that space, I'm going to do the same thing. Up arrow, down arrow. The next orbital is 2s. Up arrow, down arrow. Next is 2p. And the 2p orbital can actually hold 6 electrons. It's going to look something like that. So our orbital notation involves the arrows. And the electron configuration, now if I were to write this out, this is our manager's code. If you did that Poggle homework worksheet with us, is 1s, there's 2 electrons in that 1s orbital. 2s, there's 2 electrons in that orbital. 2p, there's 2 electrons in that orbital as well. So the next thing we want to look at is valence electrons. Valence electrons are I'll just write this out here. Let's just write it right here. Valence electrons are the outermost electrons. So they're in the outer shell. This is going to be important for us really the rest of the year because it determines how much and how reactive an element actually is or not. So outermost electrons. So when we look at something like carbon, how many electrons are in the outermost shell, in that outermost ring? Well, remember that these numbers right here, 2, 2, and the 1, represent how far away from the nucleus it is. In the Poggle, we thought of it as rings, right? So in the highest level, that's where the outermost shell, the outermost electrons reside. So in this example, we have 2 in the s orbital, and then we have 2 in the p orbital. So we have a total of 4 electrons as our valence electrons. So our dot diagram really is just an example of how many valence electrons we have. Electrons. So I'm going to write carbon here. And I just said carbon has 4 valence electrons. Right? 4. I highlighted them in yellow. So I'm going to put 4 dots around this carbon. Now instead of just doing 1, 2, 3, 4, I'm going to ask you to do it a little bit differently. I'm going to ask you to think about this carbon for reasons when we actually get to drawing and a little bit more in depth for drawing these dot diagrams and we start connecting these. I'm going to ask that you think about it in almost like 4 quadrants. We have a top, we have a right side, we have a bottom quadrant, and we have a left side. So what we're going to do is we're going to actually put 1 dot in each little section here, and just like the bus rule where these electrons don't want to be near each other, we're going to put 1 dot in each section and then once we have 1 dot there, then we'll start pairing them up. So carbon, we're going to have 1 dot on top, 1 dot on the side, we're going to have 1 dot on the bottom, and then we're going to have 1 dot on the left side. Okay. So now if we had something like nitrogen, which has 7 electrons, which has 5 in the valence, then we would add a second one on top. But since we're talking about carbon, that's not necessary. Okay. So that would be it. That would be our valence electrons. That would be our dot diagram, Lewis dot diagram. Lewis is the guy that actually came up with that for carbon. So you can try the rest of those. So one thing that I forgot to mention also that I want to just address really quickly, sorry to bounce around a little bit, but you know, we do have the cheater sheet for the orbital notation as far as the arrows. I want to talk a little bit about the electron configuration cheater sheet. So where did I kind of come up with this? Yes, what I could do is I could just kind of look at you know, how many arrows I have, but if I look at my cheater sheet here, notice in this bottom right hand corner there's actually a sheet for electron configuration. So if we zoom in on this, what we see is that we're going to start at the bottom, Aufbau's principle, and we're going to fill these up. So let's just do carbon because that's what we're focused on right now. 6 electrons, right? So I start right here at the bottom. I stay on this line, and I want to stay on that arrow line. What it tells me here on the bottom is that in the s orbitals, they can take up to 2 electrons in the s orbital. So that would be 1s2 if I was writing it out, right? 1s2. And I'm going to stay on that line. I'm going to continue. It goes dotted, and then my next electron configuration would be 2 2s, and again, that can take 2. So I'm at 4 electrons right now, and if I go back down, I'm at the p level. So I have 2p. Now notice that the p orbital can actually take 6. But I don't need 6 because that would give me a total of 10 electrons. I'm only doing carbon, which has 6 electrons. So I need just 2 more, right? So I just throw a 2 on there. So that's a quick way to use this sheet and come up with the electron configuration for carbon, or really any other element for that matter.